Welcome back to the Advanced Microcontroller series. In today's session, we are learning about microcontroller interfaces with CLCD. And here is the agenda: Introduction, Circuit on Board. So what is LCD? We know, right? LCD is nothing but liquid crystal display. LED is a feedback device. LED is nothing but light emitting diode. So what LED will do? So LED, it will turn on and turns off. So it is a feedback device. It turns on and off. On means 1 high, off means 0, means that is low. So this is the function of LED, turns on and turns off. But if I want to print message like battery low, so my aim is to print a message like battery low, then is it possible to print using LED? No. So in that time we go with the LCD. So LCD is nothing but what? Not light emitting diode. So LCD is nothing but liquid crystal display. In the PIC microcontroller, we having one of the variant LCD, that is nothing but CLCD, character liquid crystal display. So you can display all the ASCII characters. So it is used to display the ASCII characters. Along with the ASCII character, it displays few more characters including special symbols. And it also having two types of communication modes, 8-bit mode and 4-bit mode. So this CLCD is having total 16 interfacing lines. So what are the lines are there? So, and also here you can see in this display in background it having one LED. So here you can see the LED. I hope it is visible. So what are the 16 interfacing lines? So let's see one by one. So here we having 16 interfacing lines. So the first line, which is nothing but VSS. So where it is going? It is connected to the ground. And the second line, which is nothing but VDD. So it is connected to the power supply 5 volt. So here you can see it is connected to the 5 volt power supply. And we having third pin. So to control the brightness of the font, we are using this pin. So it will control the brightness. So this pin is also called as contrast control pin. So in the PIC, so open the PICSimLab Simulator. So we having CLCD. So here we having CLCD. But here you can see we having potentiometer, which connects to the pin number 3. As you varying potentiometer, we can control the brightness. So here you can see the third pin which is connected to the potentiometer, isn't it? So in the potentiometer we having 3 pins. One is connected to the power supply 5 volt and one is connected to the CLCD and one more pin which is connected to the ground. So this is what? Contrast control pin. So whatever data we want to print on CLCD, to print that data we having 8 data lines. So here you can see we having data lines. So this is what? Data lines. So those are from D0 to D7. For example, you want to print ASCII value of A. So what do you want to print? ASCII value of A. So here data is equals to A. Assume you wanted to print like this. So what is the value of ASCII value of A? So hexa value is nothing but how much? 0x41, isn't it? So what is the binary value of A? That is nothing but what? Binary value is 0, 1, 0, 0 and 0, 0, 1. 0, 0, 0, 1. So here you can see these are the data lines D0 to D7, and the CLCD is having its own microcontroller. So if you have microcontroller, then that microcontroller is able to process either data or instruction. So for example, here we having two data. Now we having only one data, right? So assume we having two data. So now I am having one more data, that is nothing but clear display. So one more is nothing but clear display. The first one is which one? Data equals to A, isn't it? So this is the first one and this is the second one. We having two data. In that, here you can see whether it is data or instruction. So this is nothing but data, right? Not instruction. So this is nothing but data. But the second one, clear display, whether it is data? No, it is nothing but instruction. So this is what? Instruction. The first one is the data. So how this CLCD will know whatever data given to the CLCD, whether it need to process this as data or instruction? How CLCD will know whether this is data or instruction and this one? So for that purpose we having one more line. So that is RS. So here you can see the pin number 4 is what? RS. So based on this line, CLCD can decide given data if it has to process as the data or what given data is nothing but instruction. So if this RS pin, so how it will know whether it is data or instruction? So here we having RS pin, but how it will know? Using this pin. So if this RS pin which is equals to 0, then CLCD has to process the given data as an instruction. So how it will know? When it is equals to 0, then it will understand the given data is nothing but instruction, not data. So if user defined this flag bit is equals to 1, so when RS which is equals to 1, then CLCD has to process the given data as data, not an instruction. So if it is equals to 0, then it is nothing but instruction. If it is equals to 1, then it is nothing but data. Now I want to print the ASCII value of A. So now what is my aim? My aim is to print the ASCII value of A. I want to print the ASCII value of A. So 0x49. So directly you can give the data or whatever binary value is there, you can give it. So what happens once you have give the data to CLCD? So it will understand the data first, then it will accept the data, interpret the data, and it will start processing the data. So what we have to do before giving to the next data to CLCD, you have to be still previous data processing. So assume here we also having data, second data, next data. So next is what? To print data equals to B. So second is what? Data equals to B. So we can't give the data continuously like this. So data equals to A, data equals to B, and data equals to C. We are giving multiple data, right, at once. So if you keep flooding whatever you want to print based on the instruction, what will happen? So if you are not give enough time to CLCD to understand the data, to interpret the data and process the data, you may end up with corrupted output or incorrect output. So what you have to do? Once you given some data to CLCD, you have to wait till that data is processed by the CLCD. So how user will know whatever data given by him is processed by the CLCD or not? For what we have some method, right, to find this, the process time. So for that we having some methods. So what are the methods? Let's see one by one. The first is nothing but delay method, and second two methods we having. The second method is nothing but polling method. So let's see one by one. So in the polling method you can poll the 7-bit. So we can also say this method as poll D7. You can say it as poll D7, or you can also say it as busy flag. So you can also say it like this. This is the second method. Now let's see about the first method, which is nothing but delay method. So what is delay method? Let's see. So you can give whatever data to CLCD like this. Data equals to A, data equals to B, then data equals to C. So you can give whatever data to CLCD. Okay, let's open data sheet and check how much time it will take to process the data. So now I am going to assume it takes 1 second. So now here data equals to A is there, right? So I am going to assume it takes 1 second time to process the data. So before giving next data, we need to provide that much delay. So here we giving delay of 1. So it takes 1 second delay, right? So I am writing like this. So after giving that much delay, you can give the next data whatever you want to display, and assume it takes half second delay. So what I am going to assume, it takes half second delay. Then here I am going to write delay of 0.5 second like this. So assume it takes half second delay to process the data. Then you have to give delay that much. After that you have to give the next data. So this is nothing but the delay method. So once you processed any data or instruction, you have to wait till that data is processed. So this is the first method. And second method is nothing but poll D7 or busy flag. So this is the second method. So polling means what? It is nothing but monitoring something continuously. But here it is monitor D7 line, read or write operation. So you are monitoring D7 line means you are read from that line or write from that line. So we can say it as read D7 line. So I am using do while loop for this. So now here we having while loop, while of some condition. So what you guys are doing, so using D7 line fall down to 0.5. So okay, so this is while loop, right? So you are using D7 line fall down to 0. So once it is fall down to 0, you can assume data is processed. Then we having what? Do loop. So do and while loop, right? So here then we having this condition. So while D7 equals to 0 means when it is fall down to 0, you can assume data is processed. So how the condition? So how the condition look like? While of D7 is equals to 0, like this. Then 2 we having this do loop, right? So how it look like? Do semicolon, then while of D7 equals to 1. So D7 line fall down to 0, so you can assume data is processed. After that do loop comes. So in the second case what we did, D7 which is equals to 1. So let's say I am giving some data. I want to print the character A. Then I am monitoring my D7 line. So we will come out of this loop, do while loop. So when condition fails, what will happen? So when D7 bit is equals to 0, you monitoring D7 line, and as soon as it becomes 0 means D7 equals to 0, you can assume that the given data is processed. So assume what? So here you can assume data equals to A. So here you assume the given data is processed. So then do loop executes. After that while D7 equals to 1. So here data is already processed. D7 equals to 0 means data is processed. Next you can go with the next data. So this method is continuously reads the D7 line. But this D7 line fall under data line? Yes. Usually this is a part of data line, right? So data line means D0 to D7. So it will do the write operation. So when we giving data, we are giving write operation to it. So whenever we providing the data, we writing the data to this D7 line. But in the polling method, we are saying what? Reading the D7 line. But when we are giving the data, we are writing to this D7 line, right? So how the CLCD will know what operation are we trying to do this D7 line, whether it is read or write? Means, so are we trying to read the data, read the D7 line, or are we trying to write the D7 line? So for that there is one more bit, so that is called read or write, or so here you can see R bar W means what? Read or write. The pin number 5. So here you can see this bit. So you have a pin number 5 for that. So if you want to read, then that time what we need to do? Same thing. So here we having for RS, right? Same like that we having for this RW. So if you want to read, then what we need to assign for this pin, that is equals to 1 when read. But if you want to write, then that time this RW, read or write, which is equals to 0. So if you wanted to write something, data equals to A, then what you can do means you can keep this R or W is equals to 0. You want to write, right? So if you want to read, then you are going to write. So if you want to read, then you are going to do like this, R or W equals to 1. So once data is written, then going to the read operation. So that is what R W equals to 1. So based on this, it is getting decide whether you are going to reading the data or write the data. But we have one restriction here. We checking only D7 pin, because manufacturer of the CLCD, whatever created this pin, that manufacturer deals only with D7 pin for the polling purpose and make sure whether data is processed or not. So the data sheet is saying you have to check the D7 line or busy flag line. That's why we are going with the D7 only. So we are not going to use D6 or D5. So we having data lines from D0 to D7, isn't it? So we are not going to use any other bit. So how you will get the schematic diagram is go to the PICSimLab Simulator. So in the boards, so here board PICGenios schematic. So this is the schematic of CLCD. So here you can see the CLCD diagram. So here you can see the same diagram I pasted here. So yeah, so we are discussing about the schematic diagram, right? So we are having one restriction, that is what? Here you can see RW pin which is connected to ground, permanently which is connected to ground. It is not connected to the any pin of the microcontroller. So if it is connected to ground, is it possible to make this pin equals to 1? No. So right now this pin is grounded, means RW is equals to 0. We can't make this pin as 1. That means we can't do the read operation here. It is always for the writing purpose. So it is not possible to read the D7 line. So can we use the second method, whether processing is done or not? Can we use the second method, polling method? No, not possible. So in our case, we always go with the delay method. So not possible to use the second method. Always we need to go with this delay method. So not possible to use. Why it is not possible to use? That we got right. Why? Because it is permanently connected to the ground. It is not connected to the any other pin. So permanently connected, right? So it is not possible to use this method. Now let's see the interfacing PIC microcontroller with the CLCD. So we need to do interfacing CLCD with this PIC16F877A microcontroller. So line number 1 is always connects to the ground, and so it should be connected to the ground. Assume this is ground. So it is connected to the ground, and this pin is connected to the power supply, 5 volt, right? So it is connected to the power supply. And third pin, which is nothing but contrast control plug-in, right? So whatever font you display is contrast, you can control by using this pin. So this pin is here, pin number 3. So that is connected to the potentiometer. So here you can see it is connected to the potentiometer. So by varying this pot, we can vary the voltage across the pin, and accordingly brightness is varying. And we are talking about the pin number 4, RS. So this is pin number 3, right, which is connected to the pot, and this 1, 2, 3, yeah, this is the RS. So yeah, so it is connected to the RE2 pin of the microcontroller. So here it is connected, RE2. And pin number 5 is RW. We already discussed, it is permanently connects to the ground. And then we having 8 data lines. So these data lines are connected to the port D, RD0, RD1, RD2, like that. It is connected to the port D. So here assume it is port D. All pins are connected to the port D. So 1, 2, 3, 4, 5, 6, 7. So before that, one more thing I forgot to tell. Not this. We are starting from this. 1, 2, 3, 4, 5, 6, 7. All these are connected to the port D. And here we having 2 pins, right? So here we also having one LED. So and this pin is anode, which is connected to the power supply, and this pin is cathode. It is grounded. So whatever data you can directly give to CLCD. For example, I want to print data. So that is what ASCII value you can directly give to the data. So to where? To port D. So how you can give means port D equals to A. You can write like this. Port D, which is equals to A, 0x41. So or even binary also you can give directly to the port D. So whatever you want to print, that 8-bit data provided here. So in the port D we having RD0, RD1, then we having RD2, RD3, up to we having how much RD7 we having, isn't it? So that is connected to the D0, D1, D2, D3, D4 up to D7. So whatever data you want to print, you can give port D directly. So here I am giving data to CLCD. So now what will be the value of RS pin? Do I need to put 0 or 1? So I given to CLCD. So these are the data, right? So not instruction. So add port D equals to A. This is not instruction. So now what I have to do means I have to wait till the data is processed once. It is processed, what character A will be printed on CLCD, right? So here D0 to D7 is entirely connects to the port D. So here what I am giving, port D equals to A. Directly I am giving data. So luckily we got entire port for data lines. But if this connection like this, D0 which is connected to, so now how it is connected? So for RD0 it is connected. Now how it is connected means, it connected like this, D0 which is connected to RD0 and D1 which is connected to RD1, like this we having. Up to D7 same thing we having. But assume what happened here, D0 which is connected to RE1 and D1 which is connected to RA2, like this, different ports we are using. Assume we having like this. Instead of having same port, what will happen here, we have different port for different data line. So if you have a connection like this, what will happen? So how data is extracted in this case? So we can't write port D equals to that particular data, right? You have to extract the given data and pass it here. So if you are doing mistake, data will be corrupted. So now how to fetch the D0 here? So which is connected to RE1. So from this data, how I can fetch D0? Can I assign directly RE0 which is equals to D0 which is equals to 1, or RE0 which is equals to not RE0, D1 which is equals to RA2 that is equals to 2. Can I write directly? No. Can I do bit operation? So how to fetch D1 which is equals to 1? So assume this data I am going to fetch. I am going to write this data equals to 1. Can I write directly? Can I use the bitwise operation? So how to fetch the data here? It is possible to process it within one instruction? No. In this case we need multiple instructions. So in this case the CLCD may execute only the first instruction, isn't it? So after executing first instruction, so it may assume I got the complete data without reading the further data. So it will start processing the data, only the first one it will start processing. The other one may assume I got the complete data. So for that purpose we having one more pin, that is what? Enable pin. So here you can see pin number 6 which is nothing but enable pin, right? So what it will do means, whatever time you wanted to take to write the data, to provide the data. So take your own time. Once you have done, you have to call this enable pin, means you need to write E equals to 1. So once you changing this E equals to 0, this enable pin from 1 to 0, it's switching, right, 1 to 0. In that time it will understand, now I got the complete data. Then it will start processing the data. So there may be a chance it assume I got complete data here only. So we are using enable pin. So you have to give the data, means port D equals to some value. So once it is done, and just you have to clock this line. What? First initially you need to write E equals to 1. So after that you need to write E equals to 0. Then it will assume I got the complete data. What CLCD will understand, I got complete data. And now it start processing. So this pin number 6 is there, right? That is enable. So it interfaces with RE1, which is connects to the RE1. So here we having, right? So this is connects to the RE1 of the microcontroller. So here. So these are the total 16 pin of the CLCD. So we having total 16 pin. Here you can see, you got some idea, right? So how it is connected. So what are the 16 pins? So what are different communication modes are there? Here we saw, right, what are the communication modes? 8-bit mode and 4-bit mode. So 8-bit mode and 4-bit mode. In case of 8-bit mode, we are having 8 data lines. So it is using all data lines. 8 data lines we having, right? D0 to, so we having 8 data lines. That is what? D0 to D7. So it uses D0 to D7 in case of 8-bit mode. So connection is from RD0, which is connected to the port D, right? Which is connected to RD0 to RD7. So we having 8 data lines. So you can process 8-bit data at a time. You can process it. So we can write port D equals to, we can directly write port D equals to A or 0x41, like that we can write. But in case of 4-bit mode, what will happen? You don't having 8 data lines. We having only 4 data lines. So what are those pin? So it takes from D4 to D7. So it takes only 4 data lines, not all. It takes only 4 data lines. So these lines are interfaces with RD4 to RD7, isn't it? So it will not interfaces RD0 to RD7 because this is the 4-bit mode. It uses only the 4 lines, 4 data lines. So now assume our data is 8-bit, then you can directly write data equals to 0. So in this case you can directly write data equals to 0x41. If you wanted to print 0x41, you can write directly. But what will happen in this case, in the second case? So in the first case it will process first, then it will yeah, it will directly process because we are using all the data lines. But in the second case, how it will do means, so it will process first 4 bit it will process. After that it will process the second 4 bit. So first it will use the upper nibble, and second it will use the lower one. So you wanted to print 0x41. So in this case, first it will do 0x, it will process 0x04, and second case it will process 0x01. So in case of 4-bit mode, we having D4 to D7 pin. So this is the difference between both two, 8-bit mode and 4-bit mode. This is the difference. So this is about the CLCD introduction. In the next session, we are going to use this thing. We are going to execute these in using the PICSimLab Simulator. But before that, I wanted to tell something. So in the PICSimLab Simulator, here you can see HD44780 16x2 under the LCD we having like this, right? So why it is 16x2? And here you can see this is the DIP switch, and you need to on this for LCD. Okay, yeah, why this is 16x2? What it means? This means you can show in 2 lines, LCD 2 lines we having. So here you can see this is the first line and this is the second line. So here you can see boxes are there, right? So total we are able to print 16 character in the first line. So cross 2 indicates you are having total 2 lines. 16 means what? In each line we can represent total 16 characters in one line, as well as in the second line also we can do the same. So that's why it is 16 cross 2. In general, how much total character we can print in 16x2 LCD? 16x2 is how much? 32, isn't it? So we can print 32 characters like this. So here you can see in the first line we having 16 character, in the second line also we having 16 character, and we having 2 lines, that's why it is 16 cross 2. So each line, each character having its own address in line 1. So it starts like this. So assume this is 0x80, and the second one is 0x81, third one is 0x82. In line to assume its address is 0xC0, 0xC1, 0xC2, like this. So how to use these address? Let's see in the next session. That's all about today's session. Thank you all.